very happy to spend some time with you today here in what is possibly the best session slot because everybody's awake and they got their coffee, but they haven't yet gone to lunch yet, to talk about iSCSI and Windows Server. And hopefully if we don't have as many AV problems as we had last time, then I'll have an opportunity to both show you about iSCSI. I've got a fun little video to show you, compliments of some friends of mine over at demartech.com, and also just to help you understand just how iSCSI can be very useful in your environments. You know, there may be, for some of you, the expectation that iSCSI is a challenging thing to work with, and in fact, it's not. And hopefully over the next 75 minutes or so, I can spend a little bit of time helping you understand how to configure it, and then also how to make it more highly available and improve some of the performance with it. At the end of the day, you might get better use out of the existing storage you already have. So let me begin with a poll here. Okay, just a poll. All right, what is the best SAN for business today? What's the best SAN for business today? What do you think? A fiber channel SAN? What do you think? Fiber channel, best SAN for business today? All right. What about iSCSI? Who's a big iSCSI fan? Yeah, give me a yeah. Right on. iSCSI, not too bad. What about, I don't know, fiber channel over Ethernet? Boo. Okay, well, we got a yay and a boo over here, right? Okay, InfiniBand. Okay, that whole new converged infrastructure thing you might be seeing a little bit about, right? What about an array of USB sticks all linked together? I've always wanted to see the monster floppy array connected together with a bunch of parallel disks, right? You know, honestly, there's an interesting answer to this question, right? The studies have shown that the answer to this question is that it doesn't matter. All right, you're like, I don't believe you, Greg. Well, a company with a three-letter name recently sponsored a survey that asks, was building your storage area network related to an implementation of a virtual server environment? And you have to kind of pull some of the data out of this, but the answer that about 134 companies that were interviewed for this particular question tends to relate to the fact that you're kind of just stuck with what you got. Right? Even though this study was virtualization related, it suggests that most people are not making decisions or business decisions about what types of storage they want based off of what types of applications they want on top of that storage. So if you have some sort of SAN, well, you're probably these days got with what you got. With that in mind, most of you today have raised your hand and said, yeah, I'm big into iSCSI and I want to know how better to configure my iSCSI and how better to eke better performance out of it. Now, we probably understand what some of the biggest detractors are for iSCSI, right? The hardest thing these days is really understanding how you're pathing iSCSI from your servers and ultimately to your storage. The hardest part is the fact that we have this great potential for oversubscription, where I have my existing Ethernet cabling infrastructure and my Ethernet devices, and I end up sending just far too much data across those devices because of all the stuff, the workloads that I have to run. Now, there is some less performance for some types of workloads, just due to some of the queuing capabilities that are in it in comparison with Fibre Channel, but for the most part, these two technologies have kind of been roughly equivalent, or at least leapfrogging each other over the years. And then finally, there are TCP/IP security concerns. Most of these relatively unfounded because a lot of us have figured out the TCP/IP problems in our network. Right? Most of these may also be our security admins that are out there telling us they just don't like it because they don't quite understand it. Anybody here a security admin? Okay, good. We can talk about them. Also, in comparison with Fibre Channel, it's much less easy to hack a strand of light than is it some sort of TCP/IP network. So we tend to be interested in iSCSI just simply because it is something that is very easy for us. Now, I will tell you that if you talk to the vendors, and you may do so here in the expo today, if you talk to the vendors may tell you that iSCSI is really kind of the wave of the next period of time. Right? I hate to say the wave of the future, but the wave of the medium term simply because of that ability to reduce the amount of cabling that you have sitting inside of your infrastructure, not having to deal with fiber, not having to deal with copper. Now, the benefits here, the fact that we have the in-house experience. You probably understand how to cable up a copper cable connection. And also, there's just that much less administrative complexity associated with creating iSCSI connections. Is it just me, or do you find fiber channel to be some kind of dark, arcane art? You know, at the TXs and your RXs and your this and your that. And every single vendor has a slightly different way in which they implement that fiber channel protocol. So a little easier on the brain in order to deal with iSCSI. It has the potential for lower costs. We've been talking about iSCSI as being a lower cost solution in the immediate past. In the immediate future, as we make that move to 10 gig and ultimately to 100 gig, the next step after that, well, the cabling costs may bring these into parity. At least that's the expectation the analysts are saying, that the costs are about the same. But for the most part, iSCSI is just very simple. Right? And I'll argue with you, right? I will bet that you can do iSCSI today. Are you comfortable with iSCSI today? Are you pretty good at iSCSI today? He's like, hey, maybe. Are you good with iSCSI today? I will argue that iSCSI is in fact so easy that a 10-year-old girl could configure it. Do you think you're smarter than a 10-year-old? Let's find out. My company, Concentrated Technology, actually engaged this testing and analysis company called Demartech, who put together a fun little video for us to explain exactly how easy iSCSI is to configure from the perspective of a 10-year-old girl. Let's take a look.
Hi, this is Dennis Martin, president of Demartech. We thought we'd have a little fun today and show you the iSCSI initiator from the viewpoint of a 10-year-old girl.
Hi, I'm Violet Westing here at Demartech Labs. Today we're going to demonstrate how easy it is to deploy iSCSI. Suppose there is a remote storage you want to access from your local computer. There are many ways to do this. iSCSI is a simple and inexpensive way to make remote storage look like a disk is attached directly to your computer. iSCSI stands for Internet Small Computer System Interface. iSCSI is a protocol to deliver block data to client computers over Ethernet. It's very flexible, working over megabit and gigabit Ethernet. Today we're deploying it over wireless. Our storage administrator has already configured a disk array with a LUN for our use with the iSCSI initiator name of this laptop. To enable iSCSI on this laptop, we access those LUNs. We need to start the iSCSI initiator tool. In Microsoft Windows, we can access the iSCSI initiator tool from the Start menu by typing in iSCSI in the search field and selecting iSCSI initiator. From the Configurations tab, you can see this computer's initiator name, which was given to our storage administrator to use to configure the remote disk for this computer to access. From the Discovery tab, we can select Discover Portal and enter the IP address of our remote storage. On the Targets tab, we can now see the iSCSI's initiator's name of the remote disk array. We activate it by clicking Connect. Choose Storage Disk Management from the menu at the left. If the LUN has not been discovered as a disk yet, select More Actions, Rescan Disks. Now that we can see the LUN as a local disk, bring it online and initialize it. Now format it and create a simple partition. I'm choosing to allow the new Simple Volume Wizards to use all the defaults. The new drive is now formatting. It takes a little time over wireless Ethernet. As you can see, the iSCSI LUN appears as a local drive to this computer. I can write data, like my school work, on this flash drive and read back from it. It works the same way it would with any other local drive. I'm Violet Westing, and it's easy to deploy iSCSI. For more information, check out the DeMarTech iSCSI zone at demartech.com/iSCSI.
If you can't wow them with great slides, at least bring in little kids, right? And in fact, what's even funnier there, if you want to stop by demartech.com, again, thanks to these guys for putting this together for us, but up in the upper right is the outtakes, the bloopers video from this, which is just as funny. So iSCSI really terrifically easy to configure. However, even though it is easy enough for a 10-year-old to configure, really implementing it into our environment today requires, well, more than really just the steps that you saw here. A single connection to a single iSCSI initiator, or a single iSCSI target, requires a bit more effort. And getting to availability and getting to higher performance requires the implementation of some additional technologies that layer over the top of what you just saw here. So if in your environment you are implementing iSCSI, and if you are, or even if you're considering it, well, you need to implement these additional steps in order to get that availability and performance that I think you're looking for. Now, built into Server 2008 and R2, just natively part of the operating system are a number of new capabilities that we didn't get in older versions. This is stuff that you more or less just get because you're running Microsoft Windows. Now, the first of which is an acceleration called TCP chimney offload, which transfers the processing of the protocol itself to the network adapter. You do have to have Server 2008 RTM or R2, and also some of the adapters. For some of the adapters, this is an extra added function that has to be specifically licensed. So be conscious of the adapters that you've created and make sure that you've added whatever necessary licensing is in there, and of course whatever accompanying cost is involved, so that you have this TCP chimney offload. Just simply enabling this chimney offload takes away all of the things that the processors would need to do and offloads it onto a specific piece of hardware and really improves the performance, not only for networking, but for the rest of the system. Virtual machine queue in Hyper-V environments also takes the processing of those individual network frames and directs those network frames to the correct target VMs. What this does is it eliminates what used to be in the previous versions of the operating system, the whole focus on CPU 0, or the first CPU in that system, to support all of the networking needs for that system. By now having virtual machine queue built into the operating system, we can now transfer those frames to the right VMs and spread the load that's still on the CPU down into the individual virtual machines. Typically, this is involved only with Intel NICs and processors, so again, be conscious about which processors and which NICs you may spec out into your servers. There's a third piece also. When we do have to do this processing on the CPU, just like with virtual machines, we also want to distribute that load across all of the 6 or 8 or 16 or 24 different processors you have in that system. And what the receive side scaling feature does, originally in RTM and now improved in R2, allows us to distribute that load across multiple network adapters and across multiple CPUs. Most of the server class NICs that you get these days, most of the ones in this generation that you're going to be buying from your major vendors are going to include support for RSS. So pay attention for that because it's going to be useful for you, particularly as you move into virtualization. And then lastly is just a direct memory architecture that we get called NetDMA that offloads the network subsystem memory copy operation to a dedicated engine. Again, moving some of that processing away. The combination of these network accelerations allow Windows itself to do better things with distributing the load across the available processors and then taking pieces of that processing and putting it into specialized hardware. Now, everybody here, right, all of you are currently running on Windows Server 2008 R2 and Windows 7, right? Of course. Probably not all of you. Those of you that are still back in Server 2003, a lot of these features are not directly available inside of the operating system. Now in 2008 and in R2, you're actually going to have these features directly available in the operating system. But if you want them in those few Server 2003 systems that you still have available, you're going to need to download them as part of the Scalable Networking Pack, which is a free download you can get from Microsoft.com. Be aware and be conscious that your NICs are going to have to support these in order to get them. If you have these, well, then you get those nice networking features. Now in terms of performance, right, just sheer performance, what I just showed you here is leaps and bounds more than what we used to have just a few years ago. And so how do we get better performance out of iSCSI? Well, more than anything, we include the better hardware optimizations. There's not much here in terms of configuration that you need to really worry about. Having those is better than not having those. That said, there are also, well, there are some considerations in terms of, well, how can I do a better job of designing my infrastructure to support the needs of iSCSI? Right? What are the best architectures involved for iSCSI? What's the best design for iSCSI? How can I best configure my systems to make it work? One of the biggest mistakes that I see when I'm running around and consulting with various clients is the assumption that NIC teaming is the same thing as teaming for the purposes of connecting to storage. Anybody here using NIC teaming as their solution for doing iSCSI storage? If you are, you're probably not getting the level of performance that you really want out of it, because NIC teaming and iSCSI teaming are not the same. NIC teaming is a driver-specific solution. NIC teaming is a manufacturer-specific solution that exists at a completely different layer in the stack than the teaming that is done for storage connections with iSCSI. NIC teaming is common in production network. It's common for your connections to your production networking, but it's not necessarily something you're going to want to do for your iSCSI connections. Number one mistake that you see whenever you're out in the field. Now, NIC teaming uses a proprietary driver. Microsoft does not support NIC teaming because Microsoft does not do NIC teaming. So the NIC teaming driver you get is one that you're getting probably from HP or IBM or Dell or whatever your provider is for your hardware. If you want to do aggregation, if you want to support load balancing and additional throughput for iSCSI, the way that you accomplish that is through one of two different protocols or approaches called MPIO and MCS. You'll see down here on the third bullet that says iSCSI teaming requires one of these two. Now, what's interesting about these two protocols is that they operate at a layer, in some cases below, well, in some cases, at a layer that is different than the NIC teaming layer. And you'll find that the various storage processors on your storage array, so you have your storage array and it's got multiple different storage processors, each of which has its own IP address. Well, the IP addresses that you assign to your storage adapters are going to create a one-to-one link, or in some cases a one-to-many link, between a storage adapter at the initiator side and storage adapter at the storage processor side. So don't do NIC teaming if you're doing it today. Switch over to using MPIO or MCS. Now, what are these things? Okay, if I'm trying to understand what the difference is between MCS and MPIO, what are they when we really dig down into the technology? You'll see here on the right, I've got a pretty interesting graphic that shows the operating system itself and all the layers that exist below that operating system. Right? So the operating system itself, when there's a call that's made to that operating system, it then calls a disk driver, which in turn calls a SCSI, which the SCSI driver itself then needs to talk to the iSCSI initiator, which ultimately gets out onto the wire via TCP/IP. Now, the multiple connections per session, or MCS protocol, as it were, is a feature or a function, a piece of the iSCSI protocol itself. It's actually built into iSCSI itself, and it operates at the layer of the iSCSI initiator. So with MCS, I can actually create multiple parallel connections to my target. If I have a couple of NICs on this side and a couple of NICs on this side, I can create connections between these two that are direct connections that enable that storage processing to occur over all of those more or less at the same time. Now, what's interesting about MCS is that MCS requires or does not require any kind of special multipathing technology from your manufacturer. This stuff is built right into iSCSI. The protocol architecture itself supports it. So if you have a storage device that supports MCS, there's really nothing more that you need to do in order to enable MCS, other than a couple of configurations. MCS has a number of different policies as well that determine how it's going to behave. So if step one, the number one problem, or the number one sort of gotcha that you can have is making sure that you don't use NIC teaming. Number two is making sure that you use the correct policy for how you're going to connect up your servers ultimately to your storage. Now you have to be aware, MCS is configured on a per session basis. So every single one that's connected into that iSCSI session is going to enjoy the same policy that you see here. There are going to be a number of different policies available to you. I'll show you what these policies look like here in just a minute. But we have a failover policy, a round-robin policy. We have a round-robin with a subnet of paths, or we can do a least queue depth, or we can do a weighted path policy. These are going to be the policies that are available whenever you first create that connection to MCS. And which one you choose could have a significant difference on how you see performance with that iSCSI connection. Now, first and foremost, and this should be relatively obvious, that first policy up there, failover, does not provide any kind of link aggregation between the different connections you have. If I have 4 connections between my server and my storage and I turn on failover, I'm only ever going to process data across one of those connections. Don't do that, unless you want to. The default policy, the one that you normally see the most, is a policy called round robin. Okay, and with round robin, if this is the default policy that's chosen, if your storage controller uses an active-active model, meaning that it can receive commands across all of its different storage processors at the same time, and whatever management application that you may layer over the top does not choose a different policy. So what round robin does is just like what it does in DNS, is it chooses a different network connection and round robins those requests over each network connection, and they're reconstructed back at the other side. There is another policy here called round robin with a subset of paths. Now what's different with round robin with a subset of paths is that I have my typical round robin connections that occur. And the round robining occurs among all the paths that I have available. In addition to those paths that are available across the round robin, there may be another set of paths, so another network connection entirely that sits idle and unused, except in the case where all of the other connections go down. A common misconception here, at least with this implementation of the protocol, is that when I lose a single connection, I can pick up that available connection and bring it back into the round robin. And that's not the way that this works. The way that round robin with a subset of paths only chooses from the failover path whenever each of the round robin paths has actually died for some reason. Now, if you want to get a little bit more useful with your configuration, we have least queue depths and weighted paths as options. Different here is the whole, well, obviously the whole round robin problem, right? With round robin, I essentially create an equal weighting for each of the individual paths that I might send that data across. But there may come the time when I have a bunch of data that gets queued up into one connection, and other data that's, well, it's not getting processed fast enough. The least queue depth policy instructs iSCSI to send the next instruction over the path that has the least queue depth. What this does is more or less load balances the aggregation as it's configured. So least queue depth, if your storage supports it, can be a relatively useful way of improving the performance because you're using those paths that have the least depth of the instructions in queue. Lastly is weighted paths. With weighted paths, I have the option of manually selecting which paths have different weightings. And so if I have one path that I know that may have a little bit better of a behavioral pattern than others, I can configure those to be weighted. You probably won't be using weighted paths unless you've done a significant amount of testing to figure out which path works better than any others. Can you think of a reason why you might use weighted paths, though? In there, over there. Okay, perhaps different speeds, or more specifically, if I have different actual physical paths that occur from my server ultimately to my storage. additional hops, for example, down one way, or other things that may be co-located on that switch. I have to be conscious with anytime I'm working with iSCSI, I have to be very conscious about all the other traffic that is occurring, not only over that single network connection, but all the other connections that are aggregated into that device, that router or switch that I ultimately plug that path into. Others? Yeah. Okay. So you said storage replication. You've got some sort of storage replication going on over there. Remember that a weighted path is going to be all of the data ultimately making its way back to the same storage location too. So I'm not bifurcating any of my storage here. I'm intending all of these connections to ultimately make their way to my same similar storage device. In the back. You could. Remember that the virtual machine actually leans on top of all of this infrastructure. So I set this infrastructure up first, and then the virtual machines actually just exist across whatever LUNs are exposed into that virtual machine. So the virtual machine, all it sees is a LUN, really. Possible. Hold that thought for just a second. So the question was, what if I have multiple LUNs? And instead of creating one giant LUN for all my virtual machines, well, what would I do? Like I said, hold that thought for just 1 second, and then I want to explain to you a solution that might work better for you. Let me spend a minute, however, and just show you some of the screens that you would see if you go about connecting and configuring MCS. Okay, I've got a little session here, and hopefully this works for us. I've got a session here, and I've taken a look at 2 of the screens for just any particular server that I might connect up to a storage array. Now, in order to make use of MCS, you'll see here's my iSCSI initiator, and I've got the properties screen, and I've got one target that I've connected to over here. Now, once I've connected to that target, the quick connect, or the simple connect, really only makes a single connection to that target. That's one NIC connecting to another NIC out at the storage array. That's a single connection. That has the potential for failure. I need to create additional connections in order to support having redundancy and then ultimately being able to load balance my traffic across both of those different connections. Now, where I look for MCS is, and I always get these confused, not there, it's here under Properties. Here under Properties of this session. Remember, because MCS is configured on a per session basis, I'm only going to be able to configure that property for the entire session and all the LUNs that are pulled through that session. And you'll see here I have the property for the session here, and I'm taking a look at some of the session information. And down here at the bottom, I have the ability to configure MCS. Okay? If I select this, you'll see the policy that becomes available. There's my MCS policy of round robin. I can select a different policy down here if I want, with subset, least queue paths, weighted paths, whatever I'm looking for here. So make sure that you're taking a look at this configuration whenever you make those connections. Now, what you're not seeing here, however, are multiple connections to iSCSI. Right? I've made a single connection into iSCSI. I need to make an additional connection in with iSCSI. I do that by running first to the connected iSCSI LUN, or the session that I've created, and reconnecting another IP address. Okay? Once I've done with that, then I can choose which path I'm looking for here, and I can additionally add more connections if I want. Most of the storage arrays, most of the storage you're working with today, may not necessarily use MCS. And I don't have any good statistics to show you which ones do and which ones don't. MPIO tends to be the protocol of choice for most of the storage vendors today, which is why you don't see MCS that much. Again, there are vendors that support that, but a lot of times MPIO is going to be the selection of choice for your storage vendor. The first thing you're going to want to do is obviously make sure that your storage vendor indeed supports that capability. Now, MPIO, or multi-path input-output, is designed to accomplish the same functional result as MCS. Okay? I have a series of NICs over here, and I have a series of NICs over here in my storage, and I want to somehow connect these NICs to these NICs. Okay? Once I make those connections, then I can fail them over or load balance them. I can add more NICs if I want to increase the total throughput. It allows me to create a very linearly extendable or linearly expandable throughput between server and storage. In the single gig, in the 1 gig world, we actually kind of have to have this, particularly with virtualization, so that we can support the needs, the throughput needs of all the virtual machines that we have on our host. So configuring MPIO or MCS is very important for supporting that extension of that throughput between server and host. Now, what's different here between MCS and MPIO is that MPIO is actually not really even a part of the iSCSI protocol. In order to support MPIO, your manufacturers, your hardware manufacturers, typically your storage manufacturer, is going to have to create a special MPIO-enabled driver. Right? Most of the storage arrays that you will use may have a special driver called a device-specific module. And that device-specific module is installed directly onto your host, and it orchestrates all of the requests across all the paths. You'll see here, this is the same graphic that I had before, but the actual team connection exists a couple of layers higher up at this point. And the orchestration is necessary at the disk driver level in order to send some piece of data across this path and send some piece of data across this path and ensure that they get processed back at the storage in the right order. So one of the big concerns, or I guess one of the big points of confusion associated with MPIO is the fact that even though this DSM is required and that you have to install and manage the DSM driver, and sometimes you even have to update the DSM driver if your storage provider creates an update to the software. One of the big points of confusion is the fact that Windows itself also includes a native DSM. You ever had this problem? Where you get the new storage array and you connect up your first server to the storage array and it just kind of works with MPIO? Right? Where you're like, it kinda works. What happened? Have you installed the left-hand DSM? Most of the time, and I can address your question later, but most of the time, these manufacturer-specific DSMs are going to solve any of the performance problems you have. Other times, you may experience one of those weird conditions where you're like, again, I'm getting kind of a connection, but I'm not getting any data through. I'm getting very poor data through. A lot of the real confusion when I have just this weird or awful performance associated with MPIO is when I'm using the Windows native DSM that doesn't have whatever additional functionality that's been built into whatever my device-specific DSM is. If it's a left-hand or what have you, those have additional functionality that's built in by that hardware manufacturer. So if there's a point of learning from this slide, the point of learning is go back and take a look at whatever DSM you have installed onto your server and then verify that, first of all, that it's not the Microsoft one, and second of all, that it's the right solution. It's the right version, excuse me, for that driver. Now, when I configure MPIO, I have a similar number of policies. I actually have one more policy than what I had back with MCS. Same series of policies. I can do failover, I can do round robin, I can do round robin with that same subset of paths, right? I can improve things a little bit with least queue depth so that I can spread out my requests across the different queues that I have. I can even do weighted paths if I wanted to. But because MPIO exists at a level that's higher up in that stack, moving back a slide, that's higher up in that stack, and thus has more direct interaction and exposure with the disk driver itself, MPIO supports a sixth policy. And that sixth policy is least blocks. Now, what's interesting about least blocks is that it's different than the least queue depth, and in some ways can be actually a somewhat superior way than the least queue depth, because this policy is going to send the next I/O down the path with the least number of data blocks currently being processed. So if I have a certain amount of data that's being processed down one channel, well, maybe this one's got less data that's being processed. Maybe then as I continue on for another millisecond or so, I've got more data going down a different path. By adjusting it based on the amount of data going down and not necessarily the number of or how many queues there have, this can actually improve performance once again. So you might take a look at these different policies to verify that you're using one that A, works with your storage subsystem, because not all of them support all of these policies, and B, actually improves your performance. I will add also that some storage, whenever the DSM is added in, whenever you add in whatever that software is to enable connection to that storage, some storage will actually add in their own custom policies, and you may manipulate them in different locations as well. So be conscious of this. Yeah, you had a question in front. I have not seen a situation. He asked if it's possible to see the vendor-specific DSM and the Microsoft DSM running at the same time and see a conflict. I have not seen that if you configure them appropriately. I'll show you here in just a second how you can do that. Somebody said in the back also earlier, I have this situation where I have lots of virtual machines, and I'm tired of creating these giant LUNs where I end up with bad performance across that LUN. One of the issues with virtual machines is the fact that I'm creating these enormous LUNs out there, right? And so when I create these enormous LUNs, I've got lots of VMs that sort of sit inside there. And sometimes, if you think of the piece of storage as a three-dimensional container, sometimes the spindles that are actually processing that data, right? You end up with too many things, too many virtual machines that are trying to access data that's too close together in your storage. Right? So of all the spindles that I have and the combs that are moving back and forth in that storage and trying to give you all the data that you're looking for, sometimes you end up with too many VMs that need to get to exactly that spot on the disk all at once. This is a situation known as spindle contention. And a lot of the storage vendors these days will have built into themselves some very magical technology that will actually move things around so that if you end up with too much stuff looking at one spot on the disk, well, maybe we'll move that stuff around so that we don't have the spindles trying to get to each other. It just becomes a physics problem with how often that comb can move back and forth across the disks as they spin around. To your question, however, even with some of these technologies, or if I don't have these technologies, there may come the situation where I just want to split off my virtual machines so that I can support different paths for those virtual machines and improve performance. It's an excellent desire. MPIO, the policies for MPIO are actually configured at the individual LUN level and not at the session level. So what this means is that I can create a policy for MPIO that's based on which LUN that I want to prioritize. Maybe I want to give a little bit of priority to one LUN over another. Well, I can do so with MPIO because that allows me that ability to configure policies on a LUN-by-LUN basis. Let's take a look at MPIO. You have a question? I'm sorry? I don't know. Come back up after class. So let's take a look at MPIO. Let me switch back over here into my system here. And what I want to take a look at here is, instead of looking at the properties screen for this connection that I've created, and I want instead to choose devices. So now I'm taking a look at the devices that are connected in for this particular this LUN that I've created. Right now I have a single disk in there. If I choose the MPIO tab, you'll see that a very similar policy selection screen appears. round robin, as opposed to, well, any of the other options that are available to me, including now the new least blocks feature. Now, if I have multiple connections here, this policy will apply to these multiple connections for this LUN. The location where I add the additional connections is the same location back here under the Connect tab. Now, when I create an additional connection, I've kind of waited to get this far so I could get through both MCS and MPIO. When I create that additional connection, this is one of the kind of the odd ways in which this control panel has been set up. I actually have to click Connect again after I've already connected to add in an additional setting, to add an additional NIC into this configuration. Now, make sure that you select to enable multipath whenever you do this, because otherwise you're going to end up with a real bad day and you're not actually multipathing across these multiple connections. When this occurs, right, when this actually happens, what I want to do is select which of the options I have available You know, when you're up here, like 5 seconds is an eternity. And then when you get to like 10 seconds or more, it ends up being even worse. So assume that I went there for a minute. There is actually another selection in here at the top which lets me choose whether it's the Microsoft iSCSI initiator or whether it's going to be one of the other DSMs that I'm using. So you shouldn't have a problem with which, this is to his question, you shouldn't have a problem to which of the DSMs you're pointing to, because the top selection in the 3 boxes that we're having issues with right now is going to choose whether it's the Microsoft iSCSI initiator or one of the other initiators that you can choose from. Okay? If you wanted to, but most of us only have a single kind of storage thing that we go to. If we have multiple storage with multiple different DSM, or multiple different DSMs. No, because it's done on a per LUN basis. Yeah. So his question was, let's say that I have multiple different storage things, right? I have storage thing A, storage array, SAN A, and SAN B. And SAN A requires perhaps the Microsoft-specific DSM, and SAN B requires some other DSM. Well, in the selection box up here, when I attempt to connect another selection here, what that's going to do, oh, here it is. I don't know why it's working now. What it's going to do is let me choose whether I want the Microsoft iSCSI initiator or one of the other installed DSMs. So this for this SAN and that for that SAN. Okay, any questions about MPIO? If you understand MCS, MPIO and MCS are remarkably similar, even though they are remarkably different at the same time. Question up here in the front. The question was, let's say I have 2 different connections, or 4, or 8, or whatever number of connections that I have from my server. We are so used to, with our NIC teaming configurations, in that we create a single IP address that the NIC teaming driver sort of handles the load balancing and failover for us. So whenever we create and connect a server to its network, we only really have to worry about one IP address. The appropriate way for us to connect up these multiple connections using the iSCSI initiator is to indeed create multiple IP addresses, both at the server side and at the target side. So when I get done down here clicking Microsoft iSCSI initiator, I'm going to have to select one of the available initiator IPs. This is the IP that's on my server. The target's going to be on my storage. I'll need to, at the first, actually create whatever IP connections I need to. So this is on the 3 net, so I'm going to set up all 4 of these NICs on the 3 net, and I'm going to call it 3.1, 3.2, 3.3, and 3.4. On the target side, I'm going to have, let's say, 2 or 4 different target IP addresses. Those 2 or 4 target IP addresses I will ultimately select down here under the bottom, and they'll appear because they've been discovered inside of my iSCSI initiator dialog box. 4 IP connections at the server side and 4 IP connections at the storage side create those 4 connections for load balancing. Another one of the confusions here is the fact that you can actually connect up not just on a one-to-one basis, but you can connect up in a one-to-many basis, right? So on my storage array, I might have those 4 different IP addresses, and I could potentially plug that same IP address into all 4 storage processors. Well, what are you doing at this point? You are indeed doing load balancing, but you're doing load balancing across one NIC as opposed to doing load balancing across those 4 NICs. So typically a one-to-one configuration is what you're going to end up with for the best performance. Other questions? In the front. Yes, you may. Absolutely. His question was, if I have one NIC, could I go to all 4 storage processors? I could, yeah. So, and indeed, there are going to be some, there are always changes depending on what sort of hardware you're using as well. His comment was, you have to be aware of your DSM and your storage before you start playing with this too much, because you're right, each different storage is going to have specific requirements for how these connections are. But in a general sense, this is generally how this configuration is done. You know, at the bottom we have some chat log on here. If you want to introduce authentication into your connections, you can do that. A lot of organizations today may not necessarily use chat. You can. It is another security feature. It's a shared secret sort of feature between the storage and the connector. And the reason for this is so that whenever you're creating a connection, that connection is authenticated between those 2 locations. A lot of organizations will separate out not only just separate connections, but also separate paths, entirely separate paths between servers and storage. In the case of entirely separate paths, well, you've got a completely segregated separate path between those 2 locations, and well, you might end up with just enough security down that road. CHAP is up to you in terms of whether it's an interesting additional security feature that you want to layer in over the top. So your question might be, which one do you use? Of the options that are available, right? Do I use MCS? Do I use MPIO? Okay, now you've told me that there are these 2 almost exactly the same looking things. And which one do I use? Well, many storage devices just simply do not support the use of MCS. Okay, when you go talk to your storage vendor, they will just tell you we're an MPIO shop. And obviously, if that's the case, well, then you're forced to use MPIO. Now, if you have the need to support those different load balancing policies on a per LUN basis, such as in the case of virtual machines and wanting to prioritize virtual machines, as the person in the back said, you might want to go down the MPIO route if it is an option indeed for you. Because the MPIO is the only protocol or the only feature that allows policies to be done on a per LUN basis as opposed to a per session basis. The hardware iSCSI adapters that we see today, or hardware iSCSI HPAs, tend to support MPIO over MCS. Not that many of us are probably using them these days. Anybody here using a hardware-based adapter? Got one guy over here, got a couple of people over here. What do you think of them? Over here, somebody else have one? What do you think? What are you thinking? They're absolutely flawless. I like that. You know, for the rest of us, a hardware iSCSI HPA is a NIC. And so the storyline, at least as it was told to me, was the storyline goes that these hardware HPAs kind of came out back before a lot of those acceleration features were implemented into the operating system. Right? And so the need for having these additional accelerations on that card were what created this separate class of devices we think of as hardware iSCSI HPAs. But as we've moved in this direction, for a lot of us, those technologies, at least in a workable enough fashion for our needs, have just been included in with our traditional HBAs, with the HBAs that we're using today. And so the HBAs we're using today, considering the cost, are kind of good enough. Somebody had a question back in the back. I'm sorry? I'm sorry, what did you say? And boot from ice and boot from SAN. You know, those also improve the whole experience involved with boot from SAN as well. Good point. So if you are using the rare iSCSI HBAs, you know, they tend to support MPIO. Interestingly enough, MPIO is not available on XP Vista 7. In order to get MPIO, you actually have to install a separate feature on top of Windows Server. Actually, kind of one of those forgotten features. All right? The multipath I/O feature is simply not available in Windows 7, Vista, or XP. So if you're intending on using iSCSI for any of these configurations, well, you're probably going to have to go to MCS. At the end of the day, studies have shown that MCS has this teeny, tiny little blip of better performance than MPIO. Arguably, they're enough of the same that you can just say that they're the same. I mean, there's this little tiny bit. It involves more processing power in order to support MCS. Some of the offloads, some of the accelerations reduce this impact, but for our intensive purposes, when you figure out all the other things that make up a system, really, well, they're just about the same in terms of performance. So use whatever works for you. Of all of these 5 options, the one at the top, whichever one is configured for your storage, is probably the one that you're going to end up using. Now, many of us are here because we want to figure out how both of these work with virtualization. Right? There are a lot of different ways in which we can configure Hyper-V in order to support its connections to iSCSI. And most of the best practices today suggest using a combination of network aggregation with network segregation. Okay? If that doesn't sound completely opposite, then continue listening. The aggregation of networks is important so that we have this improvement of throughput and this improvement of the failover capabilities. Right? If I have 4 networks, if I have 4 network cards, I can connect all 4 of those network cards together using either one of those 2 protocols to improve the total throughput between my server and my storage. This is a good thing. Right? But at the same time, I don't necessarily want to create a condition where I oversubscribe the traffic, where I have too much traffic that's going out of this server, where I don't have enough network capacity in order to support the needs of the virtual machines that are running on that host. Who here has some sort of network monitoring solution at the host level, or really at any level, that can tell you whether or not you've maxed out that available capacity between your server and your storage? Who here has one? We got one? Got very few of you do. The rest of you, hold up your hand like this and go like this. Because if somebody calls and says the Exchange server is slow today, what do you tell them? We're getting right on that. Somebody had a question down here in the front? So network, I'm a big monitoring guy. You talk to me and I will slap your head about network monitoring or even server monitoring every time you hear me in any kind of session like this. Because particularly in the case of virtualization, the number one activity in virtualization today, the number one activity, the absolute must-do activity in virtualization is performance management, right? What is the industry average total across every industry, whether you're baking biscuits or building vehicles? What's the industry average for CPU utilization for a Windows server these days? 3%, 5%, I hear 7% sometimes, right? So we've got this 3, 5, 7% of total utilization for our servers, right? And then we go, ooh, virtualization, yeah, buddy, I can squish all those physical machines into one host. Are you familiar with the laws of physics? If I take 7% host and I put it on a server with another 7% utilized, what do I get? I get 70%. So all of a sudden we move into a world where we're not worried about we didn't have to worry about performance because we had so much raw capacity that we're better optimizing our capacity, that we have to monitor for that capacity. So that is my soapbox for the day. All of you go buy a network monitoring solution from one of them Expo people and tell them I sent you. We can, with Hyper-V, configure Hyper-V with some in multiple different configurations. Okay, and I'm just going to give you just some basic drawings here because I don't want to get too deep into the architecture. Obviously, with a single server, if I have a green set of storage connections and a red set of production networking connection, the best way for me to configure that server so that it has redundancy and at least a better or larger amount of throughput between server and storage is to use those redundant connections. Hyper-V server, network switch, 4 connections. Very useful. If I also want to improve performance and protect myself against the device at the network side from being one of the limiting factors, I can add a redundant path into this configuration. So my Hyper-V server now not only talks over redundant connections, but those 2 connections are pathed out across different pieces of networking hardware. This allows me to ensure that no single path can go down and take with it my Hyper-V environment. It also has a tendency to load balance that stuff quite a bit better. Now, most of us aren't using Hyper-V in a single server configuration. What we're using it is in some sort of clustered configuration. And with that cluster configuration, at best, we have to have at least a minimum of 3 connections, right? Something for storage, something for networking, and then something else for all of those cluster bits that we're not exactly sure what we need that other connection for, even though Microsoft makes us have that other connection. So I have those 3 minimal connections there, but this isn't enough really to support the availability needs of a Hyper-V cluster. Separating those out, adding aggregate paths, so I'm combining these network connections together, and then adding in an additional connection here for management separates out live migration, separates out management so that the processes of doing management and the processes of doing live migration also don't impact my storage or my production networking. That's why you see 6 connections here instead of just 5. Now, taking this all the way through to its ultimate conclusion, a fully redundant Hyper-V cluster with all of the bits connected together and supporting redundant path is going to look somewhat like this, with plenty of different network connections that are bonded together to support the throughput needs of my server. Now, that green box, or that green line right there, is really important because I show 2 connections there, but it really could be any number of connections, right? Any number of NICs that are necessary to be bonded together to support the throughput needs of my server. Back in the early days of virtualization, we focused a lot on processor and processing power as the limiting factor in why Hyper-V and other virtual providers just didn't work that well. If we were experiencing a performance problem, we really pointed at processing power or lack thereof as being the reason why we weren't having that good performance. These days, the evolving conventional wisdom is moving to the fact that the actual problem may not necessarily be a lack of processing power, but a lack of IOPS between the servers and their storage. So for those of you, the 99.9% of you that aren't monitoring your network connections between servers and storage, one of the reasons why you might not be getting the performance that you're looking for out of Hyper-V is because you haven't supplied enough input-output operations per second, or IOPS, speed, total amount of round-trip time between, hey, change that from a 0 to a 1, and hey, I got that, from server to storage and back. So these tools assist you with ensuring that your IOPS supply is at least greater than the IOPS demand that your virtual machines are placing on that host. Thoughts about that? Yeah, there. So you have to be always conscious about also the difference too between the width of the connection and the speed that data can get back and forth, right? The total round trip time. The width of the connection is sort of like the number of lanes on the highway, right? The throughput of that connection. If you have more lanes on the highway, you can support more cars on that highway. But if all the cars are Maseratis as opposed to being, beat up old pickup trucks, those cars are going to operate with a lot faster performance as well. Yeah, so there's two calculations here. Good point. His comment was the vendors, and correct me if I'm wrong, the vendors are saying, look at IOPS, but throughput is important as well, right? And you're exactly right in that both of these measurements have to be taken into account. I have to measure not only the IOPS, or the total round trip time, how fast I can get data back and forth from servers to storage, but I also have to be aware of how wide the pipe is, my throughput. So the number of lanes on the highway supports better performance, but at the same time, how fast those cars are is a measure of IOPS. Now, the speed of those vehicles on the highway, right? You all know. What kind of car do you drive? 4Runner. So he drives a 4Runner, right? And a 4Runner goes, I don't know, 60, 70 miles an hour, right? A little bit more than that, and maybe not so great. I don't know. So that 4Runner can drive relatively fast. It might even be able to drive 100 if there are no other cars on the highway. But if I got a lot of cars on the highway, how fast are you driving? The speed of everybody else. So when I end up with situations of contention, the contention is driven by not only the throughput. When Atlanta turns the 6-lane highway into an 8-lane highway, well, we get a little bit of improvement in performance, don't we? But not as much as we really wish, considering the 2 years it took to actually extend the 2 lanes. So I have to be conscious of both the throughput and the IOPS. Both of these are very important for understanding what that total performance is. Now, 10 gig is a significant game changer when it comes to really evolving just the whole way we approach this problem of performance with networking. Not only IOPS, but throwing throughput at it. Right? With 10 gig, I'm suddenly taking the 1-lane highway and I'm turning it into the superhighway, a 10-lane highway. You can almost, if you take a look at your total utilization across any kind of connection, substituting a 10 gig connection for a 1 gig connection is like moving the decimal over in what percentage utilization you're seeing. And again, that's a rough number, but if you were 70% utilized over a 1 gig connection, you're only going to be 7% utilized over a 10 gig connection. So moving to 10 gig is significantly useful for virtualization environments particularly to help you improve that whole performance problem because you're making the size of the highway wider. Many of you'll hear the term converged infrastructure. There's a couple of different terms out there. I like to call it the first series of server hardware designed with virtualization in mind. Right? These types of virtual hardware tend to support 10 gig E because 10 gig E creates that whole virtual I/O notion that really improves performance there. So I know you didn't want to come into this session today and hear me tell you buy more stuff to improve performance, but in some cases, buy more stuff will improve that performance because of that whole highway mentality. Now there are some configurations you can do. Right? Hyper-V has some ways in which you can improve performance. For example, change the VHD type you use. In RTM, VHDs, according to Microsoft testing, we all know how important Microsoft testing is, 96% of native, right? In R2, that is improved to essentially native, or without virtualizing at all, when you're using a fixed VHD. So a fixed VHD is going to support really as close to native as you're going to get with the performance of those disks. Now, pass-through disks have always operated with almost no overhead at all. Right? With no overhead at all, a pass-through disk, or a disk that's connected via iSCSI to the Hyper-V host and then presented into the virtual machine, that pass-through disk is really going to operate with real native speed. Now, the only part where you really get any kind of loss of performance at all, now, back in RTM, dynamic VHDs, anybody try this? They got got better in R2. The testing suggests that in R2, dynamic VHDs get about 85 to 94% of native performance. Now, the good thing is dynamic VHDs are really useful, right? I'm just like you. I don't like to burn up a bunch of disk space if I don't have to because, well, disk space is, you know, it's not that it isn't cheap. It is really cheap these days, but moving it around is getting harder and harder as the sizes have been getting bigger. So if you're willing to pay that 6 to 15% of performance in order to support dynamic VHDs, that may be useful to you. But if you can't, moving over to fixed is one option for you. Now, those VHDs tend to be the most commonly used option for most of the system drives in our virtual machines. But pass-through disks are an option as well. Right? Most of the time, we don't necessarily choose pass-through disks for performance, at least in R2, but because we have different requirements that are based on the workload itself. I got some backup and recovery tool that I need to be able to back up and recover directly, right off of the SAN. I got a big, extremely large volume that I don't want to have to worry about encapsulating into a VHD. I've got some storage management software I have to worry about, or maybe I've got some application compatibility issues there too. We don't choose pass-through disks because I want better performance. I choose them because I have some sort of application need or requirement for making that decision. Now, there is a fourth option. Fixed VHDs, dynamic VHDs, pass-through disks, and then this fourth option here is what we call iSCSI Direct. iSCSI Direct is essentially when instead of connecting iSCSI to the host, I can instead connect iSCSI to the virtual machine directly. Now this is cool because the host doesn't participate in this. Right? I don't have to worry about what the host sees because the VM, no matter where it goes, as long as it has IP connectivity, it's going to be able to talk to its storage. That's pretty sweet. It's great for administration. Even the LUN isn't available to the host. Also really cool. The LUN can be hot added and hot removed without requiring a reboot, which is fantastic. And it also has this transparent support for the VSS hardware provider. I can do clustering. So iSCSI Direct is relatively good. Now, there were some concerns in previous OS versions like RTM that iSCSI Direct had a loss of performance because in previous versions, the direct connection of iSCSI into that virtual machine didn't enjoy all of the acceleration features I just talked about. Today in R2, a lot of that has gone away. Right? With R2, testing has shown that there is virtually no degradation in performance when I connect a LUN directly into the virtual machine as opposed to onto the host and use a pass-through disk. Okay, this has kind of been validated through testing. My company, Concentrated Technology, concentratedtech.com, hired Demartech, which is a testing firm, to actually give us some real numbers as to how much performance do you lose if you do that direct pulling into the VM. And these numbers are literally hot off the press. I got them literally last night at 11 p.m. And this is a comparison of 10 gig iSCSI performance, plugging it into the host as opposed to plugging it into iSCSI Direct. And you can see here that our IOPS achieved is about, what is that? Somebody give me a percentage there, like, 10% more, 10% less? So a relatively small drop in performance there, relatively small drop in read and write average latency when I'm really stressing an Exchange server. I'm using JetStress to stress an Exchange server, 1,500 mailbox sizes of 75 megs, a static Exchange IOPS of 0.18 and 2 threads. So if you need the rawest performance, use pass-through disks. If, again, you're willing to pay that 10% little bit of performance loss, the iSCSI Direct configuration is a little bit easier to use. It's a little bit more manageable to use. And so it might be more friendlier for you. Now take a look here. Here's another image that I have. Here's a perfmon trace, again, involving 10 gig performance. If I have a single Exchange server and I stress it using JetStress to its maximum capacity, that single Exchange server just pounded on, maxed out at right around 37% of the 10 gig pipe. So 10 gig can support significant amounts of network throughput. This is the evidence here coming out of an extremely stressed Exchange database. Some people may talk also about jumbo frames, and I myself have also talked about jumbo frames as well. And jumbo frames and its support for iSCSI. My friends at DeMarTech have, in some of their testing, have suggested that even though jumbo frames allow those larger packet sizes to be transmitted and received, the results have been a little variable in what benefit you get out of the additional cost you get for making the change. You have to have the same size across all the adapters and switches and storage targets and everything in order to support jumbo frames. Any misconfiguration anywhere, well, you don't end up with jumbo frames, and the MTU size gets splintered and reduces that performance. Some storage devices don't really fully support jumbo frames or haven't even tuned themselves for jumbo frames. So you have to be conscious about which storage provider you have and even if they support it. So if you've been told do jumbo frames, as I've always said, test, and make absolutely sure that you've got the jumbo frames configured across the entire infrastructure, or you're just going to lose one missed step, one missed hop in the chain, and you're going to lose something. In terms of 10 gig versus 1 gig, 10 gig adoption is definitely increasing. Also, again, the guys at DeMarTech suggest that the adoption in SSD themselves is also improving performance. And SSDs, putting an SSD between you and your storage can actually significantly improve your performance there, as well as kind of a caching function local to that storage, because SSD is just so powerful and so much faster than having a disk spinning around in a drive. So if you want to get a copy of that 10-year-old video, feel free to drop by youtube.com/DeMarTech, or there are a number of different iSCSI-related configuration guides that the guys have put together over there. Thanks again to them for helping us out with some of these slides. I really appreciate that. That's DeMarTech.com. But I appreciate the opportunity to get to talk with you today about iSCSI. I will be here all week. Again, my name is Greg Shields. I'm with Concentrated Technology. That's concentratedtech.com. I travel to every single conference. That's what I do, is travel to conferences. And if you are interested in any of our slides, we give away all our slide decks for free. So if you'd like, I can give you a card that'll show you where you can get those free slide decks across every single conference this year. I really appreciate the opportunity to talk with you. Have a great day.